radiations and Davisson-Germer experiment. So basically, black body radiations are radiations which are emitted due to vibration of particles. A black body is an object which absorbs and emits all the radiations that fall on it. And the intensity of the radiation does not depend on the nature of solid, but it depends only on the temperature. Now we're going to talk about spectral distribution of energy of a black body. It's going upside down. Yeah. So basically we have plotted the relative power output with respect to wavelength. This is trying to show us the dependence of energy density on the wavelength and the temperature. As we can see, the energy is not uniformly distributed at a particular temperature. At a given temperature, energy density is increasing with the increasing wavelength up to a point. This point is lambda max. Beyond this point, even though we see the energy wavelength increasing, the energy output is actually decreasing. And the increasing temperature increases the energy of all its spectral components. The shift of the peak was found to obey this empirical relation given by Wien, which is called Wien's displacement law, which states that lambda max into temperature is always constant. Basically, the radiations emitted by a black body has a wide spectrum of wavelength according to the graph as shown before. So the amount of energy contained in a spectral region within, let's say, lambda to lambda plus T lambda is given by this equation. This is proposed by Wien, where A and B are the respective constants. This equation seemed to have worked really well for short wavelengths, but there were few deviations seen for longer wavelengths and higher temperature. Now Rayleigh disagreed with this point. So he suggested his own equation with another constant C. He could not accept the fact that at infinite temperature we can obtain a finite energy. Finally, Planck came into the picture. He stated that the energy density of a black body radiation can be discovered only if light emission is considered to be a quantum phenomenon. So Planck suggested his radiation formula, which represented the energy density in terms of frequency. So this is the formula given by Planck to us. And now suppose h nu by kT is considered to be greater than 1, we obtain Wien's law equation. And if it is lesser than 1, we obtain Rayleigh-Jean's law equation. The most important aspect of Planck's hypothesis was the new idea of discontinuous emission of radiations. Planck's hypothesis basically has three flaws. One, that it is empirical. The second flaw is that it is statistical, where it refers only to the time averaged behavior of an oscillator. The third flaw is that it does not tell us about the flaw in Maxwell's equations. Basically, it only tells us that about the energy of an oscillator that it must possess to be in a thermodynamic equilibrium with a radiation field. So that was black body radiation, and now I'm going to talk about Davisson and Germer experiment. I'm drawing a rough diagram of the setup of Davisson-Germer experiment. So this is basically the diagram, this is the setup for Davisson and Germer experiment, where this is the nickel target. This is electron gun from where the electron beams are emitted. This is a tungsten filament. We connect the slits to high tension battery and the filament to low tension battery. So Davisson-Germer experiment was basically performed to explain the wave nature of particle. This all started with the accidental discovery of diffraction of electrons, which confirmed the de Broglie hypothesis. Now, electron from the electron gun is accelerated by an electric field of known potential difference coming from the high tension battery. Electrons are collimated into a single beam by passing them through slits. Now they are made to strike over the nickel target, which can rotate about its axis perpendicular to the plane of paper. Now, the collector is basically a Faraday cylinder which measures the intensity of scattered electrons by the nickel target. This collector is connected to the galvanometer. Basically, the deflection observed in galvanometer is directly proportional to the intensity of beam entering the collector. This whole apparatus is set up in an evacuated chamber. So the known potential difference between the nickel target and the filament is considered to be 40 volts, which is increased gradually. Now we have plotted graph against theta and the intensity of scattered collector current. Starting from 40V, if we see, the curves are smooth. Slowly, as we are approaching 54 volts, we can see a bump appearing. This actually signifies that electrons were associated with waves which after scattering gave rise to constructive interference. At this point, the incident and the scattered beam makes an angle of 65 degrees with Bragg's planes. Now, finally, according to Bragg's law, we obtained this equation where n lambda is equal to 2d sine theta. The calculation is shown as such. So according to Davisson and Germer, we obtained a lambda equal to 1.662 angstrom, where in this equation d is basically the space between Bragg's planes, which is considered equal to 0.91 angstrom, n is taken equal to 1, and theta, as I mentioned earlier, is 65 degrees. Now we are applying the same relation, in de Broglie's relation for matter waves, which states that lambda is equal to h upon mv, which is equal to 12.27 upon root v, to make the calculations easier. We obtained a bump at 54 volts. So we substitute 54 volts over here and we obtain 12.27 upon root of 54, which is equal to 1.673 angstrom, which is very much closer to the value which we have obtained here. This shows us that Davisson-Germer are verifying de Broglie's hypothesis. Davisson-Germer experiment basically has three demerits again. One is that this is less straightforward, as energy of the electron is actually greater than the work function. The second demerit is that the electron speed inside the crystal was greater than outside, whereas it should be the other way around, and the lambda obtained according to de Broglie's equation was shorter. The third one was restricted occurrence of maxima due to multiple interference by different Bragg's planes. So with this, we end our seminar. Thank you.